All right, so what we're going to do is example number 1. Remember, whatever I write down, I want you guys to write down. And example number 1 gives us a function f of x is equal to x squared. Now, you are probably in Algebra 1 a lot, you saw equations like this. Y equals x squared. They kind of mean the same thing. Okay? This is pronounced f of x. So we're going to do a question where we find the domain and range, but I'm going to kind of go back and teach you a little bit about functions, function notation. So what I'm doing right now is explaining what a function is. We need to know and understand what a function is before we can find the domain and range. So remember that the question is asking us, what is the domain and what is the range of this function? Okay. Well, remember that a function, I'm going to write this in a different color. A function is like a mathematical machine. What I mean by that is you're going to have an x value that goes into your function f, and then it's going to spit out an output, which is f of x. Now, you're used to thinking of it as in terms of x and y, but x is what we call the input, and f of x is what we call the output. And actually, I apologize. I'm going to erase this, and I'm going to put the f above the box. So I'm going to get a number. I'm going to plug it into the equation. The equation is going to do some math, and it's going to spit an output. So, for example, if I say x equals 1, I'm going to plug that into the machine. My function is x squared. So I'm going to think x squared, but in this case, when I plug in a 1, I'm going to say 1 squared. So then my output, y, which is the same as f of x, is equal to 1. So a function has an input, which is the x value. You do some math to it. When you're done, you get an answer, which we call an output. That's the y value. Okay? So I'm going to check for understanding. Thumbs up if what I said makes sense to you guys. Thumbs down if you're kind of a little lost. Okay. All right. Good stuff. Yes?
So like the function would basically be just sort of like in this situation, the function is like x squared.
Yeah. So the function's like a machine. So I don't know if you guys are familiar with, but like these scissors, okay? The metal parts of these scissors, they have regular metal that goes into a machine. The machine like does stuff to it. It like crunches it, presses it, cuts it, right? There's another machine. It does plastic molded injection, right? So there's a mold that they put the metal inserts in, and then they shove a bunch of plastic in there, and the plastic kind of forms to the mold. So when you put stuff in a machine, in other words, this doesn't start off looking like this. There's an input that goes into the machine. The machine does some work, and then it puts something else out. That's what we're doing mathematically. We have an input value of x. We plug it into the function. The function does some math, and it spits out an output. Does that help? Okay. So we're going to do that, and that machine is what I have circled here, x squared. So he was saying we're going to do x squared. Yep, every time we're going to do x squared. On example 2, we're going to do 3 over 4 times x plus 2. So the function changes. Okay? All right. So the domain, and I'm going to type this so you guys can see it. They're asking us to find the domain, but the domain is all possible x values, and the range are all possible y values. And I'll thin that out a little bit so it looks a little better. Okay. So when the question says what is the domain, what it's really saying is what can we plug in this thing for x? And then when it says what is the range, it's saying what are all the possible y's? In other words, domain, what do I plug in? And then range, what do I get out? In fact, let's write that down. So this is the domain. What are all the terms that I could plug in for x? And this side is the range. What are all the output values that I'll get? Okay. So in Algebra 1, when you learned how to graph a function, you basically plugged in values for x, right? And then got a corresponding y value, and you graphed those points. Were you able to do that, though, virtually? Did you get to practice that virtually? Probably not as much as you would like. Okay. Well, we'll review it. If you're not 100% comfortable, usually in a regular school year, like you do that on the first day and you do it until the last day. It's ingrained in you. But even I know with my students that I taught Algebra 1, and then when I taught them Algebra 2, they were a little lost. And that's okay. We'll figure it out. We'll get you there. So there's one way. So basically the machine can be represented. In other words, this function, I can look at all the x values and all the y values in the graph. If I only had a device that would graph this function. How about a graphing calculator? Turn on your graphing calculators. Your screen will look a little different probably when you first turn. Well, I don't know. We've been using them all day. It'll probably look like this. So when you get your calculator turned on, the first thing I want you to do you see that second button? That second button is like the shift button. You know how when you type on a keyboard, you want the capital letter? Well, it's similar on your calculator. There's a lot of stuff. Notice that the second button is blue, and there's a lot of stuff printed in blue. So anytime I want to put something in blue, I have to hit that second button first. There's also some stuff in green. That's the alpha button. Okay. So if you want something that's printed in green, you hit green, alpha, plug it in if you want something printed in blue. But what I want all of you to do is hit the second button and hit mode. And what that does is that takes you to the home screen. It quits wherever you're at, takes you to the home screen. And if you don't have your screen clear, hit the clear button. Now, when Mr. Adams is teaching you guys, if you're wondering what button did he hit, where did he go, what did he do, the buttons that I hit are always down here in the order that I hit them. So I hit the second button first, then I hit the mode, and then I hit the clear. What happens? Mr. Adams will teach you how to do something on the calculator. Smart kids get curious and they go, oh, I wonder if I hit this button. And they kind of are doing something different, and they, out of curiosity, play with the calculator a little bit, and then they jump back in and they've lost their place. That's okay. Just know that if you lost your place, those are the buttons that I'm hitting, okay? Is everybody on this screen? Yeah? Okay, good. So now, whenever we want to graph something, see this button up here that says y equals? You see that? Click on that bad boy, and you'll probably get this equation. That's not the equation we want, is it? So if you have something in there, just hit clear. Some of you might actually have x squared. Yeah, good, you're done. No, hit clear anyways, because I want to show you how to put in the x squared. Okay. So if you hit clear, that equation is x squared. So see this x button right here? You guys see that where the mouse is hovering? You see where I'm at? You guys see it up there? Hit that button once. Okay? Now we need to put that 2 up in the top. The way that we put stuff up in the top, the way that we raise something to a power, it's called the caret symbol. See this little symbol right here? It's called the caret symbol. It looks like an arrow pointing up. Click on that. See how it puts a little box up on the top? What do I need to hit next? 2. So now I have a graph. I've plugged this function into my calculator. So I'm going to hit graph. Do you see what I see? Yeah, I'm going to help you with the zooms in a second. Some zooms are one way or the other. So if you're having a hard time seeing the graph, if you go to zoom, I like zoom standard, which is option number 6. So if you hit the zoom button, zoom standard, that just takes you from -10 to +10 in the x direction and -10 to +10 in the y direction. That's a good start point. So go ahead and move your cursor down to number 6 and then hit enter. Okay. If you're not able to get to this screen, raise your hand. I'll come around right now and help you. Anybody else need help? We killed this one. Sometimes when kids put them away, it doesn't make contact. No, I started from the office. Does anybody get an error message?
Yeah, I did. Did they put in the like I know what is
You hit this button, correct? Oh, that's why. So you got little zooms. They go down. No. Anybody else get an error message when they try to graph it? Does everybody have a graph like that on the screen? Remember, I'm still recording, you guys. All right, let's keep going. So you should. Does everybody have this on their screen, on their calculators? If not, raise your hand. Okay. So I'm going to take a little picture of that because I'm proud of the work that I've done. Good job, Mr. Adams. And I'm going to put that in the notes. So now at this time, what I'd like for you guys to do is kind of sketch that in your notes. Okay. And as you're kind of sketching that, by the way, we're not even close. What was the question I was asking you guys? What is the question you're being asked to find? Domain and range. Good. Good. So we're doing all this stuff. We're almost there. We're almost there. I had to remind you guys what a function is, and I had to teach you how to do the graphing calculator. Okay? At some point in time, you'll know what a function is, and you'll know how to use the calculator, and then you just go down. All right. So remember that your domain are all the possible x values. Now on the graph, what are the x values? So the x values, this is the x-axis, right? That's the left to right stuff, isn't it? So when I think in terms of x, I think about going left to right, right? So any point on the graph, I've got an x value. Now, consequently, the up and down is what? Y. But now that we're fancy pants and we're in an Algebra 2 class, we're going to refer to it as f of x. So it really looks more like this. You guys are used to seeing x comma y, but now that you're fancy pants, it's x comma f of x, right? So my x is the stuff left or right, and my y is the stuff that goes up or down. Yes?
So if we were to like try to plot something on the graph, how x and y numbers, like if there was like a point at like 1, 1, would we like write x as 1 and write f as 1?
Yeah, so I'll show you that. But yeah, you can plot points, just very specific points on the graph if you want to. You could look at it too. So, for example, if you in this screen, if I hit trace, as soon as I go into trace mode, if I enter in 1, it'll say, what is the y value when x equals 1? When I hit enter, it pulls up when x equals 1, y equals 1, and that's the point. Yeah. Okay. Let me finish our thought, and then when I'm done recording, I'll explain the subtle difference between the two. Because I think your question is, well, what's the difference between y and f of x? Why are we all of a sudden calling it f of x?
Not really, but it's just like how exactly a lot of this stuff. Would we kind of like change f to 1 but still leave the x in parentheses?
Oh, okay. Yeah. So, okay, I'll try to answer that. Okay. So, for example, when x equals 3, so traditionally for this function, when x equals 3, my y value would equal 9, right? Because 3 squared is 9. Does that make sense? Yeah. So I think he's saying, well, how does that work? Well, there's a couple of ways you could look at it. Actually, what we're saying is x is equal to 3, and f evaluated at 3 is equal to 9. That's the subtle difference in the notation. And the reason we're writing it that way is I'm letting somebody know 9 comes from something. It's a very specific equation. It's a very specific type of question or equation, and we call that equation a function. And then we give the function a name. In this particular case, the name is f. You can have g of x. You can have h of x. Does that help?
Yeah.
But when we think about the xy plane, that output is always the up and down. So you could think of it like this. You could think of it as the left and right, this is the input, and the up and down is the output. Does that help?
Yeah, I see.
Okay. Good question. Good, deep question. All right, so let's jump into it. We're going to do the domain first. So the domain can be written a couple of ways, all right? But what we want is we want the lowest possible x, or lower bound, for x, and then we want to figure out what the upper bound is, the highest possible value for x. Okay? So what I'm saying is, what is the lowest number I could plug in for x? Well, I can figure that out by looking at the graph. Okay? I just have to look at the graph, and which way is the lowest x? If I go this way, does it get lower? Yeah. What happens when I go this way? It gets higher. So what I'm going to do is I'm going to follow the graph, And we know that the graph goes on forever. But we think about it in terms of left. How far left can we go with this graph? Negative infinity. It's infinity in the negative direction. Does that make sense? So this can go to negative infinity. It goes on forever. Remember, negative infinity is not a number. It's a concept. So we're saying it can go all the way over. How far? All the way. Negative infinity. How are we feeling about that so far? Okay? Okay. Now, we need to find the upper bound. The upper bound is how far to the right can we go? Can we go to 10? Yes. Can we go to 11? Yes. Can we go to 10 billion? Yes. What's the furthest we could go to the right? Infinity. Positive infinity. So our domain is x is between negative infinity and positive infinity. That is our domain. And we got that just by looking at the graph. Just by looking at the graph. So now we want to do the range. Now for the range, we're going to look at the graph up and down, right? So again, I want the lower bound and the upper bound. So I'm going to look at this graph and I'm going to follow the graph. What's the lowest possible y value? 0. I'm never going to have a y value on this curve less than 0. That's the lowest it goes down, right? Y equals 0. Does that make sense? So my lower bound is 0. Can I include 0? Yeah, because 0, y equals 0. Because this point right here, that point on the graph is x equals 0, y equals 0. So that means that we can include the 0, right? This is x, comma, y. So because I can include it, I'm going to put an equal sign here. Does that make sense? I'm teaching you a lot of stuff. We're almost done, actually. What's the greatest y value that I can have, though? When we go up and down, like if I go up, how far does that go up? Forever. So I heard somebody say infinity. Yep, positive infinity. So my upper bound is positive infinity. Now, to write it in interval notation, if I'm including 0, I'm going to make a bracket. Does that make sense? Why did I make a bracket instead of a parentheses? Because of this little line right here. I'm saying that y equals 0. And it goes all the way up to infinity. For infinity, you got to do the parentheses. Okay? How do we feel about that? What was the question we were trying to figure out a long time ago?